Hello my dear friends, so this is Supriyo from Supnit's classes and we are starting a new exam oriented series over here on inorganic chemistry. We will be covering study of compounds, that means ammonia, HCl, HNO3 and H2SO4, all this in a phased manner and definitely not the chapter wise fashion that you may have learned the earlier stages. So, see, before exams you have to study or rather revise in such a way so that that is in line with the examination question pattern. So, you gain much more confidence with it and definitely you are going to ace the examination, whichever examination it is, with this kind of study methodology. So, let us start right away with our first topic, reactions that matters. So, our first topic is reactions that matters. So, there will be many reactions, but there are certain reactions which are getting asked time and time again in examinations, and along with that we have to keep in mind all the observations that are related with the reactions. So, how to do it? So, just do it with me, keep your pen and paper ready, and I think with time you are going to be acing this reactions that matters very well. Our first reaction, Na2SO3 plus HCl. Wow, a very simple reaction, Na2SO3 plus HCl. So, HCl means over here we are taking dilute HCl. Okay. So, if we take dilute HCl, that means HCl will show simple acidic nature, and whenever a sulphite is reacted with acid, then it gives salt, sulfur dioxide and water. So, herein we are going to produce salt, NaCl, sulfur dioxide plus water. You need to balance this. It is balanced now. Along with this, we also have to remember or rather understand what kind of other questions that can be asked over here. Here we can get a question which is nothing but state one observations. So, what will be the observation over here? We can clearly see here a gas is getting evolved and the gas is nothing but SO2. The gas is nothing but SO2, and this gas have a smell of burning sulfur. So, what we will write? A gas is evolved with a smell of burning sulfur. Okay. So, that is what is evolved over here. Many times we are very much confused that whether I should write that this gas turns lime water milky, this gas turns acidified K2Cr2O7 green. No, you should not write that, because whenever certain statement is given to you that Na2SO3 is reacted with HCl, that is the reaction that on which you have to write the observations. That is the question that is given. You need not discover or innovate another test for it and write that. You can do that in case of distinguish, but not in this case. Your observation will be simple, a gas is evolved with smell of burning sulfur. Let us go for our next reaction. FeS plus HCl. This will be our reaction number 1, this will be reaction number 2. Okay. So, FeS plus HCl will give FeCl2 plus H2S. Again another gas is evolved. So, here we have to balance it, 2HCl, done, it is balanced. So, in this case what will be the observation? again a gas is evolved with a smell of rotten eggs. A gas is evolved with a smell of rotten eggs. Please write down with me. Okay, done. So, this is how you should write the observations. Many times we are very much confused how to write the observations. So, it is very simple, right? Whatever you see, whatever you get smell of, write the observation. Our next reaction is copper carbonate CuCO3 plus HCl. So, I think you guys should be able to do this reaction by yourself. Shouldn't you be? I think you should. Carbonate plus acid, again HCl will show acidic nature. So, here we will get CuCl2, the salt, plus CO2 plus water. Any carbonates or bicarbonates, whenever reacted with any dilute acids, will give you salt, water, carbon dioxide. Carbonates and bicarbonates, salt, water, carbon dioxide. Sulfides and bisulfides, salt, water, sulfur dioxide. Okay. So, here also a gas is evolved. Okay. So, this gas, the CO2, whenever it is evolved, it has no smell at all as a SO2, but it gives a brisk effervescence. That is like the whenever you open a cold drinks bottle, it gives you that whoosh, that is called brisk effervescence. So, guys, this will be what will be your observation? Brisk effervescence is observed. Okay, guys. So, I hope you are able to understand how the observations are written. Any problem, please let me know. Any problem. Next is another important one, lead nitrate. Let us go for this one. Lead nitrate with HCl. Lead nitrate with HCl. Let us see what is formed. So, here lead is there, here there is chloride ion, so it will be PbCl2, which will precipitate, and along with that 2 molecules of HNO3 will be formed. But what will be my observation? My observation will definitely not going to inculcate HNO3 in it. My observation will incorporate only PbCl2 because that is a precipitate. So, PbCl2 is a white precipitate. Okay. So, your observation should be white precipitate is formed. But if suppose it is said that lead nitrate is dropped into HCl solution and after that the solution is heated. So, you must remember PbCl2 is a precipitate in cold water, but in hot water PbCl2 gets solubilized. So, remember this white precipitate, if such a thing is asked that the mixture is heated, if it is not heated, the observation is pretty simple, white precipitate is formed. If it is said it is heated also, then you will write the precipitate dissolves when heated, because you also write this reason, because PbCl2 is soluble in hot water, because PbCl2 is soluble in hot water. I hope the things are clear. We are going for the next reaction, the reactions that matter. Number 5. What is our number 5 reaction over here? Well, this time we are going to react it with AgNO3. We are going to take AgNO3 with HCl. AgNO3 with HCl will give you a white precipitate of AgCl plus HNO3. So, our primary observation is white PPT is formed. White precipitate is formed, that is our primary observation. However, you need to remember an important thing, that is AgCl is soluble in ammonia solution, that is AgCl is soluble in NH4OH. Okay? Very important part, have to remember this thing. This small things create lot of difference in chemistry, but however this kind of things are very few, you just need to jot it down somewhere and revise it time and time again, that is it. Number 5. What is our number 5 reaction? Okay, our number 5th reaction is Na2H2O3 and HCl. So, here we will get NaCl plus SO2 plus water plus S. So, there will be, see here the observations are a little bit different. Why? Because there is a precipitate of sulfur over here, and along with that you are also getting SO2 gas. So, both are very important in case of your observation. So, what should be your observation? Here your observation will be a gas is evolved with smell of burning sulfur and along with that you can write yellow precipitate is formed. So, sulfur will form that yellow precipitate, which is the case with the reaction. So, I hope we have done this 5 very important reaction, will help you, and we are going to do more. Our 6th reaction now. So, in this number 6 we are going to write 3 reactions on a trot, that is, one is MnO2 plus HCl. So, if you see this reaction exemplifies the reducing nature of HCl. So, here HCl acts as a, it is write this down also, HCl acts as a reducing agent. Okay, this is very important. So, here HCl reacts with MnO2 to give MnCl2 plus Cl2 plus water. MnCl2 plus Cl2 plus water, and the similar kind of reaction happens even if you go for PbO2. So, if you go for PbO2, almost the same reaction. So, as you can see, the reaction does not change over here, just lead replaces manganese, and also you can go for red lead. This is called red lead plus 8HCl, 3 PbCl2 plus Cl2 plus water, and the same reaction almost happens with KMnO4, 16 HCl. Water. I hope each and every one of you are clear with the understanding of these reactions rather, because here we are basically revising the facts and not going into the depth of the reactions, but each and every reaction can be explained over here in details, why this is happening, why this is formed, everything can be explained. Okay. So, if you are not clear with that, please get clarified, because in that case you do not need to remember the equations. Okay. See over here, in all these cases a single observation is very much common. In all these cases there is chlorine evolved. So, we can write common observation is greenish yellow gas is evolved. Common observation is greenish yellow gas is evolved. Okay. And there will be certain observations which is not common, because the substances are different. Things like, see, this MnO2 has black color and this becomes colorless. So, this black color MnO2, when you put in concentrated HCl, this black color dissolves into a colorless solution. So, you can write this black colored substance dissolves to form colorless solution. Okay. What about the next one? Okay. So, PbCl2, as you know, will form white precipitate. So, this will be an observation if you do not heat it. In both the cases there will be white precipitate. What happens to the next one? This KMnO4 has a pinkish or purple color. So, this color diminishes. When you put into concentrated HCl, this color gets diminished. Okay. So, these are the various different observations for different reactions that we have discussed. Okay, guys. So, coming to the next set of reactions. So, our next reaction over here is aluminum nitride. So, here also you are going to take two reactions, aluminum nitride and magnesium nitride with warm water. Can you complete the reaction? Aluminum nitride and magnesium nitride with warm water will give hydroxide plus NH3. So, I am writing the balanced reaction. Aluminum hydroxide plus NH3. Please note down everything. Remember, as you are writing, you are understanding, everything is getting set in your brain, and that is very important. Here it will be NH3 done. Next here 3 MgOH whole twice plus 2 NH3. Always try to do one thing, make sheets of unbalanced reactions and balance them. This gives you a good practice of your calculation skills, and also in chemistry this gives you a practice of your balancing skills. So, in both cases over here, if you see, there is evolution of ammonia. So, what we should say is, the observation over here is a pungent smelling gas is evolved. So, the observation here will be pungent smelling gas is evolved. And also a very important identification test for ammonia, which you may note down, that is, whenever a glass rod dipped in HCl brought near ammonia, it gives dense white fume. So, we will write this also over here. dense white fumes are found. Very important identification test for ammonia. Coming to our next reaction. Okay. Number 8. 8 starts with a balanced number of 8, 8 NH3 plus 3 Cl2 gives 6 NH4Cl. This is the case of excess ammonia with chlorine, and in this case ammonia acts as a reducing agent, chlorine acts as an oxidizing agent, and the important thing over here is, I will have to disconnect this call. Important thing over here is dense white fumes of ammonium chloride. So, this is the observation over here. Our next reaction is number 9, same reaction, but in this case it will be excess Cl2. So, NH3 plus 3 Cl2 will give NCl3 plus 3 HCl. Here this is a liquid actually. So, this liquid is yellow and explosive. This is nitrogen trichloride. So, in this case what will be our observation? A yellow explosive liquid is formed. Okay. A yellow explosive liquid is formed. Our next reaction is heated copper oxide with ammonia. Very common reaction, many a times asked in examination. So, we cannot leave it open, करना ही करना है. So, here you have to give heat, it will reduce it to copper oxide is reduced to copper. This reaction shows reducing nature of ammonia. Please write down. Whatever important information is there, we have to write down. This reaction shows reducing nature of ammonia. So, let me complete the reaction now. 3Cu plus N2 plus 3H2O. So, what will be my observation in this one? Black color, this CuO is black color. So, this black color CuO changes to reddish brown. So, what I will write? Black solid changes to reddish brown color. Okay. Black solid changes to reddish brown color. Very important observation which you need to do. Okay. Our next reaction is oxidation of ammonia. So, there are two reactions in this case also, NH3 plus O2. So, one is normal oxidation, that is 4 NH3 plus 3 O2, this is normal oxidation of ammonia, it will give you N2 plus water. So, observation is very important over here. The gas bonds with a greenish yellow flame, bonds with a greenish yellow flame. The gas burns with a greenish yellow flame. Excess oxygen, if you give excess amount of oxygen, then what will happen? There will be tinge of reddish brown fumes. Okay. But that is very rare. Normally the gas will burn with a greenish yellow flame. Okay. Coming to catalytic oxidation of ammonia, this is also a very important reaction. So, whatever observation we are doing, the reactions are also very important. So, never ignore the reactions, balanced reaction is very important. In case of platinum 800 degrees Celsius, this reaction is the starting point of Ostwald's process, that is also important point, I will write it down. 4NO plus 6H2O. So, I will write this important point. Starting reaction of Ostwald's process, and by Ostwald process what do we manufacture? We manufacture HNO3. Here there is one of the very important observation is, as this reaction is an exothermic reaction, the platinum which you give as a catalyst continues to glow. So, that is the observation. Platinum catalyst continues to glow. Okay. So, with this we are going to end today's session on reaction that matters. There are many more reactions which we are going to discuss in our tomorrow's session. Okay. So, till then I hope each and every one of you have copied each and every point and have done these reactions and observations along with me, and have gained enough confidence on how to write the observations of the reactions, and which is very important, you have to keep this revising time and time again. That is it, up to the examination, and then it is over, right. Okay, with that I thank every one of you for joining. Thank you very much.